just to recap, matter can be either a pure substance or a mixture. If it's a pure substance, it's an element or a compound. If it's a mixture, it can be well mixed, homogeneous, or chunky, heterogeneous. So this kind of slide kind of emphasizes these two types of matter over here. Notice that they have a definite composition, and with composition then we'll talk more about properties, but they will have specific properties associated with them because they have that definite composition. All right. Contrast that then to dun 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 mixtures. Now, mixtures are great too if I think about it. Mixtures, we are just physically combining two or more pure substances, and those substances could either be elements and or compounds. But the fact that we're just physically combining them means that we're just kind of tossing them together. The cool thing about just tossing them together is we can basically untoss, or we can separate them back out into their components. So I mentioned the two types of mixtures. Homogeneous is well mixed, has the same composition throughout. Heterogeneous mixture, I called it chunky. It means that if you grab like location A and location B, you're going to have different amounts of the components. Your mixture will not be the same throughout. Mixture, like I said, you can go ahead and undo your physical tossing process. You can undo a physical mixture, break it back down, although you're not really breaking it, separate it back out into its components by physical means. This is kind of fun. The ratio of the things you're mixing together can vary. So an example I like to mention is if you are making Kool-Aid. Okay, so Kool-Aid is basically water and sugar and a little bit of flavoring that the Kool-Aid packet brings. But if you go with differing amounts of sugar and water, you're going to get different properties, different sweetnesses of those Kool-Aids. So you could have one Kool-Aid with a half a cup of sugar per gallon of water, 2 quarts of water, versus 1 full cup of sugar per 2 quarts of water. Okay, the second one is going to be a lot sweeter than the first one. So you get to pick the ratio, and as you pick the ratio, as you vary the ratio, the properties will change. Like I said, you can separate the two out by physical means. So here we have a couple of mixtures. If I told you that this is mostly water, for instance, you'd say, well, something's coloring that water. So it's water and something else. And the fact that it is, we'll call this A. I'm going to make this into a question. We'll call this one A and this B. Okay, this is also kind of a water-based situation. Notice it's not clear, so that purple means there's something. And then we also have some solid here. So my question now is, which is an example of a homogeneous mixture? I don't know if you already have the answer on your slides or not. Which one is homogeneous? Is it A or B? Homogeneous, question mark, A or B? Okay, I'm going to go ahead and do the builds here. And hopefully you said that A was homogeneous. The fact that the B one down there looks kind of chunky means it's heterogeneous. Okay, again we have two mixtures. The first one, if I told you it was mostly water, the fact that I have a blue color here tells me that it's not pure water, and this is clearly a mixture. Why? Because you see different colors. Okay, so hopefully you would tell me the one on the left is homogeneous, the one on the right is heterogeneous. This is a good example. If, for instance, we wanted to get back our black in one pile and our tan in another pile, we could physically take a while, pick them out, and make two different piles. This one, if we do have something dissolved in water, what do you think? Maybe evaporate off the water and leave the solid residue behind? Okay, that would be separating them back out again. So here is an example of a mixture in this picture. This is a figure from your textbook. I think this is pretty cool. So air, you don't have to be in the ocean to be in a mixture, okay? Air actually is mostly nitrogen, go figure. And it's about 80% nitrogen and about 20% oxygen. Now notice that what your author's done is to show the nitrogen as being diatomic and the oxygen as being a diatomic. So that's why it looks like that. In general, I would say that we have a homogeneous mixture, or depending upon where you're at in the atmosphere, you might get into some sort of heterogeneous situation. But down here, this is kind of cool. This is seawater. So let's see if we can find all the components of seawater. Well, there's our H2O molecule. And the salt part in seawater is NaCl. We saw the video a little while ago that actually NaCl is Na plus and Cl minus. So actually, your Na plus is represented here, okay, and your Cl minus is represented here. So I'm kind of liking seawater as being what? Another homogeneous mixture.